Hi Hamsini. Now let us know about internal aldol condensation. Internal aldol condensation, it is a reaction where carbon ion addition takes place within the same molecule. This usually occurs in those compounds that have diketone, dialdehyde, or a compound with an aldehyde and a ketone. Let us take one example, that is a diketone. Here you have a double bond O and here's another double bond O. This is a diketone. Now here carbon ion addition occurs within the molecule. Here you have alpha hydrogen at this place, another alpha hydrogen over here, that is alpha hydrogens, and these are also considered as alpha hydrogens because this carbon is alpha carbon. Carbon adjacent to the carbon bearing double bond or the functional group is called alpha carbon. Therefore over here it has got 4 alpha carbon atoms. These two and these two. Let us number this one as alpha prime. Okay, now if carbon ion addition takes place between alpha carbons, that is starting from here, then it leads to the formation of 1, 2, 3, 4, 5, 6, 7 membered ring. It leads to the formation of 7 membered ring from, that is alpha to alpha prime. It leads to a 7 membered ring. If carbon ion addition takes place between alpha prime, then it starts from here 1, 2, 3, 4, 5. That is, here it starts from alpha prime over here 1, 2, 3, 4 and 5. It leads to 5 membered ring. From alpha prime to alpha, it leads to the formation of a 5 membered ring. When compared to 7 membered ring, 5 membered rings are more stable. Thus, the correct way of addition should be from alpha prime starting from here, leading to the formation of a 5 membered ring. Let us look at the mechanism. Over here you have a diketone. Double bond O, double bond O. When it is treated with a dilute base, from here, that is alpha prime, a hydrogen is abstracted, leading to the formation of carbon ion. Here you have double bond O, and here you get your carbon ion. Next step, that is your second step, addition of carbon ion onto the carbonyl group. So here pi electrons are drawn towards oxygen, thus leading to the partial positive charge on this carbon. Now here this negatively charged carbon ion attacks this carbon and thus it forms a 5-membered ring. This is your 5-membered ring. Let me show you, and once again formation of a 5-membered ring. This is the 5-membered ring which will be formed. Here you have oxygen with a negative charge and an alkyl group, and over here you have C double bond O with the carbon with CH3. Now here this upon treatment with water, when it is treated with water, you get a 5-membered ring. Here you have OH, C double bond O, CH3. This is alpha carbon and this is your beta carbon. Hence, you get beta hydroxy aldehyde. This is your beta hydroxy aldehyde. As we have already learned, beta hydroxy aldehydes, when they are treated with an acid, dilute acid like hydrogen chloride, it leads to the formation of alpha beta unsaturated compound where OH from here and a hydrogen from here is lost, leading to the formation of a double bond. Here is a double bond formation and you have C double bond O, CH3. This is about internal aldol condensation. In internal aldol condensation, you need to take care of the ring that could be formed. It should be preferably 5-membered or a 6-membered ring formation. In case of internal aldol condensation, you will have different sets of alpha hydrogens. You have to select such a set where a carbon ion that is generated would preferably lead to the formation of a 5-membered or a 6-membered ring. When you compare a 5-membered or a 6-membered ring with 7-membered ring or 3-membered ring, they are preferably more stable. Let us look at few examples to understand this. Here you have different sets of diketones. First one, CH3, C double bond O, CH2, CH2, C double bond O, CH3. Now here you have this carbon that is your alpha carbon and this is another carbon which is your alpha carbon. Also this is another alpha carbon. So now here if you look at this, if at all a carbon ion is generated from alpha carbon instead of alpha 1. Then it will be 1, 2, 3, 4, 5 membered ring. From alpha to alpha, it is a 5 membered ring. Let us check if it is alpha 1, then it will be 1, 2 and 3. 3 membered ring, that is from alpha 1 to alpha. That is starting from here. If you take this as the carbon ion, then the ring that will be formed will be 1, 2 and 3. 3 membered ring. If you consider this one as your carbon ion, then the ring that will be formed will be 1, 2, 3, 4, 5. 5 membered ring. As 5 membered ring is more stable, formation of a compound with 5 membered ring is preferable. Let us take another example. Here you have CH3, C double bond O, CH2, 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 C double bond O, CH3. Now this is one alpha carbon, this is another alpha carbon, whereas this is alpha 1 and this one will be alpha 1. Similar type of carbons and hydrogens, alpha 1 and alpha 1, alpha and alpha. If you have carbon ion formation over here, then the nature of ring will be 1, 2, 3, 4, 5, 6. From here it will be a 6 membered ring. From here, if you start, it will be a 6 membered ring. If your carbon ion is over here, then your ring will be 1, 2, 3, 4. It leads to 4 membered ring. 6 membered ring is more stable compared to 4 membered ring. Therefore, this is preferable. Let us take another example. You have CH3, C double bond O, CH2, 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 C double bond O, CH3. So, here you have alpha and alpha carbon, hydrogens on these alpha carbons, and here you have alpha 1 and alpha 1. If your carbon ion is generated from this carbon, then let us count the number of carbons which will be involved in the ring. 1, 2, 3, 4, 5, 6, 7, 8. It leads to the formation of an 8-membered ring. If at all this is your carbon ion which you choose, then let us see the ring that could be formed. 1, 2, 3, 4, 5, 6. 6-membered ring will be generated. So which one is more stable? More stable will be 6-membered. So when you have got to deal with internal aldol condensation, you have to preferably choose the carbon ion which leads to either 5-membered or 6-membered ring formation. This is about internal aldol condensation. Thank you.